Good afternoon, students. We'll start now. Okay, so we are meeting after so many days. I think after 1 week. So in the last class, I think we had on Wednesday. So we discussed the implementation part of KNN algorithm, right? And before that, we have studied this concept called curves of dimensionality. So this instance based learning algorithms are very prone to this problem, that is curves of dimensionality. So where when you have the high dimensional data, then that creates a problem. And we have seen this one example where we had 20 dimensional data. Out of that, only two attributes or the features were relevant and others were irrelevant or redundant. Okay, so even if the two instances which are identical, they will have values, very closer values for these two relevant attributes. They may be very far in the remaining 18 attributes. Okay, and thereby the distance will be, the resultant distance would be higher. Okay, and that's why when you have such misleading data, your final prediction will be misleading. Okay, so the problem is those irrelevant attributes. Okay, so that's why we have to go for the feature selection or feature reduction. Okay, so we'll discuss that topic today. Okay, so all these processes comes under this main task known as the feature engineering. So this feature selection, feature reduction or extraction comes under this feature engineering part. Okay, so consider the example. Consider you have IoT application. Yes. Okay, so you have the IoT application. So your data is coming from various sensors. So this is the data and it is coming from various sensors. So this is just the raw data. Then you do some pre-processing on it, right? So in pre-processing, what you do? Pre-processing, right? So in pre-processing, we clean this data, right? So if some values are missing, then we impute or we delete that. We may sample this data. Okay, we will find out some random samples out of that, or if required, we format that data. Okay, formatting means we will transform that data from one range to another, right? So we will format this data. Okay, that is our pre-processing task. Okay, now till this point we have not excluded any feature. We have considered all the features, all the values coming from this sensors. Okay, now then we have the feature engineering part. Okay, so this is my feature engineering module, feature engineering, where I will either go for the feature selection or feature reduction. Okay, so here we will transform our data. Okay, so my columns will change here. Either I will select, okay, if I am getting 10 columns here, I will be getting, okay, consider if I have selected only 3 relevant attributes, okay, then after this module I will be getting only 3 features. Okay, so with the help of feature engineering I am transforming my data. Okay, and then this will be fed to my ML algo. Okay, whatever algo you are working with, it will be fed to my ML algo. So far in our lab session we have not considered this module, right? We were working on all the attributes. Okay, I think in the first lab, which was based on the linear regression, we tried to find the correlation and we have selected the highly correlated features, right? So there we have done the feature selection manually. Okay, so today we will be seeing different libraries for feature selection. Okay, so how to get the top k relevant features. Okay, today we will study that. Okay, so what do you mean by feature engineering? All these processes will be done in the feature engineering. So definition is the process of transforming raw data into the features that better represents the underlying problem to the predictive models resulting in improved model accuracy on unseen data. Okay, so by doing this, what we are doing, we are removing irrelevant attributes or redundant attributes. Okay, so our model will become more simpler. Okay, there will be less noise, that means the chances of overfitting will be less. Okay, that's why by doing this we'll get improved model accuracy. Okay, the main subtask are feature selection. So here we will be selecting the most relevant features, okay, from many features to the few that are useful. And in feature reduction or extraction, what we do, we transform our data into the new features. Okay, so we project the features onto the new dimensional space, and that dimensional space will be very less in number. Okay, so the automatic construction of new feature from the raw data. Okay, so first we'll discuss the feature selection. So in feature selection, what we are doing, it is a process of selecting a subset of relevant features. Okay, we are selecting a subset of relevant features. Okay, so in that example, out of these 20 features, only 2 are relevant, others are irrelevant or redundant. Okay, so we are trying to select only these 2 relevant attributes, and this process is also known as variable selection or attribute selection. Okay, now what are the benefits that we will get by doing feature selection? It helps in creating an accurate predictive model. Yes, right. So if you are working with only the relevant feature, that means your model will be more specific, right? So you will get more accurate predictive model. Then it is used to identify and remove unneeded, irrelevant and redundant attributes. Okay, now this attribute will not contribute to the accuracy part. Okay, they will not help you to increase the accuracy, but in many cases it actually decreases the accuracy. Okay, they will misguide your model. Okay, so by removing such unneeded, irrelevant or redundant attributes, okay, you are working on the most relevant attributes, right? So your accuracy will increase. Okay, so this attribute sometimes will not contribute to the accuracy, or sometimes it actually decreases the accuracy. Okay, so you will remove such attributes. It reduces the complexity of the model. Yes, so now you are working on the smaller set of the features, right? So your model will be much simpler. Okay, its complexity will be reduced, and we have seen in one of the lecture, in that we have discussed underfitting, overfitting problem, right? If you go for the complex models are more prone to the overfitting problem, right? So they get misled by the noise. Okay, so by removing irrelevant attributes, you are reducing the noise, thereby it reduces the overfitting problem also. And if you are working on the smaller set of training examples, it will reduce the training time also, right? So those are the benefits that you get with the help of feature selection. Now we'll see different techniques of feature selection. Okay, so we have this library in sklearn, that is feature selection. Okay, we'll see 2 or 3 methods which are available in this library. First is the removal of the features with lowest variance. Okay, so now one example I can give you is, let me copy this. Or I can write here. Okay, yes, so we were talking about this low variance feature. Yes, so consider this is my data set. I am having multiple features, and there is one feature, this X feature, which is having 0 variance. This is my X10 less, let's say, and this is my output attribute Y. Okay, there are many features here. Okay, and in this feature all I am having is 1. Okay, For all the samples we have one entry, that is 1. That means the variance for this attribute is 0. Okay, there is no variance. Okay, now in the output variable I will be having different values. Let's say if I am having a 3 class problem. Okay, so I have A, B, C classes. Okay, so I will be having different values here. Okay, now is it contributing to this classification? Is this feature doing anything? Is it going to help us in classifying? No, right? So when we know the variance of any attribute is very low, we can exclude that feature. Okay, even if we have, let's say, 0, now there is some variance here. Okay, but is it contributing? No, right? So with the help of this we can say model, okay, we can remove such attributes. Okay, so one example is given here. So here we have 3 features. Okay, now if you observe the feature 1, so it is having 0, 0, 1, 0, 0 and 0. Okay, so in only one row it is having different value, rest it is having 0. Now, so if you want to remove such attributes, attribute which is having, so if you want to remove all features that are either 1 or 0 in more than 80% of the samples, okay, then we can go for this model called as variance threshold. Here you set that threshold, okay, so 0.8, and if you transform it, so that first feature will get removed. Now if you observe, from the 3 feature we are getting only 2 features. Now observe the second feature, 0, 1, 0, 1, 1, 1. Okay, so out of the 6 samples it is having 0, 1, 0, 1. Okay, so in the 2 rows it is having 0, in remaining 4 rows it is having 1. Okay, so it is kept in the output. See, 0, 1, 0, 1, 1, 1, right? So it is there. First column is removed. Okay, so this is first model that we have under feature selection. Okay, so you can remove the feature with the lower variance. So set the threshold accordingly and such attributes will be removed. Second model that we have is univariate feature selection. So univariate. Okay, so what is the working principle of this model? So here we consider one feature at a time, okay, and we will calculate its score, okay, and we have different models here. Consider this one, that is select k best. Okay, so you set the value of k. Now this model will run, we will consider one feature at a time. It will calculate its scores, and it will select the best k models, best k features. Okay, so here consider, so along with the k value you have to provide the test value also, test that you want to carry out. Okay, so we have different options here. So for regression we have F regression, mutual info regression, these 2 options, and under classification you have these 3 choices, chi-square test, F classif, mutual info classif. Okay, so you have to give this parameter also. Okay, so I am using this select k best and I have set k equals to 2. Okay, so this will give me the best 2 attributes which are having the best score. Okay, so here I am using the iris dataset. Okay, so if you remember, iris dataset has the 4 attributes. Okay, so by using this model I will get the best 2 attributes. Okay, so we will try this in our lab session. Okay, we will see its effect on the accuracy score. Okay, now if you compare these 2 models in the in this low variance based model, we have not considered the output variable. Okay, so it is somewhat like a unsupervised learning. Here you are just considering the input attributes. Okay, but in univariate feature selection you have to consider the output also. See, in the transform I am giving the output parameter also. Okay, so each time it will select one feature, it will try to feed that data, okay, and calculate the corresponding score, and finally it will select the best k attributes. Okay, so that's why it is called as univariate, okay, feature selection. The next technique that we have under feature selection is recursive feature elimination. Okay, so now here we'll start with all the features, okay, and we have to decide one value here. Let me open that article. Yes, here you have to decide this step value also. So this step attribute will decide how many feature you want to exclude in each iteration. Okay, and this attribute is saying that at the end how many features do you want. Okay, so here what I am giving the model also that need to be used. Okay, so this technique is known as recursive feature elimination. Give the model that you want to use, then how many feature do you want and how many feature you want to exclude in each iteration. Okay, so we'll start with all the features. Okay, by this value I want to say that I will be excluding one feature. Okay, and then I will go in a recursive loop. Okay, on the reduce set I will do the same process. Okay, so this is the recursive feature elimination. Okay, so what is happening here, the least important features are pruned from the current set of features. That procedure is recursively repeated on the pruned set. Okay, pruned set until the desired number of features are selected. So this is recursive feature elimination. The next one is the select from model. Okay, so here what we do, so when you train any model, you get this coefficient score. Okay, now this coefficient score, in coefficient score you will have the coefficient values for each attribute. So in this select from model you will refer this coefficient scores, okay, and select the best features. Okay, so now how this is different from the previous one, here we are eliminating one by one, right, but and here also we consider that coefficient scores. Okay, but we remove here, right, one by one we remove the features with the least coefficient value, right, but here we select the coefficient with the best coefficient values. Okay, so few examples, the variants are given here. See the corresponding code. If you don't give any value, it will give us the best attribute actually. Okay, so if number of attributes to be selected, if you don't give that, then it will give us the single feature. Okay, so this is select from model, it refers to that coefficient scores. Okay, so this is regarding feature selection. I hope you have understood this. Okay, so just remember the summary of this concept, feature selection. Okay, so you have n number of features but select the most relevant one. Okay, so either you can delete the feature one by one or you can select the best k, right. So in the first approach we have removed the feature with the lowest variance, right. In the second one we have selected one feature at a time, okay, and we have find out the score of each feature, and then using this one select k best, we have selected the best k, right. Then recursive feature elimination, you start with all the feature and eliminate one by one. Okay, and you have to set the limit. Okay, how many features do you want, right. So that is feature selection. The next one is feature reduction. Okay, so in feature reduction, so here we assume that all the features are relevant, okay, all are having the equal importance, but we want to transform our higher dimensional data set into the lower dimensional data set. Okay, so this is comes under dimensionality reduction techniques. So here it is a process of automatically reducing the dimensionality of the features into a much smaller set that can be modeled. Okay, so we'll be seeing PCA under this category, that is principal component analysis. Okay, so we'll not go in depth regarding the mathematics of this. Okay, but I will tell you the concept. Okay, so what happens in PCA? Okay, so I have this article. So we'll start with the two-dimensional data. Okay, so I can plot my data. So consider height and weight is given, so I can plot that data. Okay, now what we try to do in PCA, so consider, so if you observe this data, so the variance of this data is highest in this direction, right? Yes. Now, so this is our data samples. As you can see, the variance of this data sample is highest along this axis, right? Now in PCA, we'll try to come up with this line, and this line is known as the principal component. So this is our first principal component, which is trying to capture the variance in this direction. Okay, so we are having the highest variance along this direction, so this is our principal component number 1. Now second axis where the data is varying the most is this one, right? So they are distributed along this axis, right? So this is our PC1 and this is my PC2. This is principal component 2. And remember, all the principal component will be orthogonal, they will be perpendicular. Okay, so now in PCA what we do, we project this data point onto this. So we project this data point onto this principal component. Okay, so this is how they will be projected onto the principal component 1. On principal component 2, so this point will be projected here, then here, and then this one here, and this one here. Okay, so now if I transform this, so this is my principal component 1. Okay, so this is that line. Okay, and this point will be projected here, 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 and here, right? Okay, and this is my principal component 2. Now by doing this, what we are doing, we are trying to capture the variance present in this data. Okay, so along this axis, this is the variance, right? Variance यानी कि क्या है, वो मीन से कितने vary हो रहे हैं, right? Okay, so we are trying to capture that. Okay, the highest variance was along this axis, right? So we have captured it in along PC1. Then secondary, it was having the highest variance in this direction. We have captured that. Okay, now what is the use of this? Consider the 3D example also. Okay, so this is the data given. As you can see, if I pause, okay, I cannot pause this, but we are having the 3 clusters, right? So I can yes, I can move this point. See, so on the x-axis I have PC1, PC2. Let us try to capture the highest variance. Okay, so see, this is the highest variance that I can capture along the PC1 and PC2. Yes, right? वेरिएंस यानी कि देखो यहाँ पे see, if I move that, okay, so this is the highest variance that I can capture, right? So this is along PC1 and this is along PC2, ये PC2 के along है, right? Okay, if I go with different selection, let's say if I move like this, okay, am I getting more variance now? No, right? In this case I was getting this much variance, here I am getting very less, right? Okay, so PCA tries to find that axis where the variance is most, okay, so that will be your PC1. Then after that, what is the direction of the most variance, right? Okay, so if I go with the actual PCA, if I apply the actual PCA, so this is the distribution that I get. Okay, so this is my principal component 1, this is my principal component 2, and as you can see here I am getting 3 clusters. Okay, I am able to find those 3 clusters if I go with this principal component. Okay, so now I have the 3-dimensional data, okay, where I can see 3 clusters. If I want to reduce the dimension, I can consider only PC1 and I can go with that. Okay, from the 3 feature I am able to reduce the dimension to 1. Okay, if I want more information I will add next principal component. Okay, consider high dimensional example. So here I am having 17 dimensional data. Okay, so here we have the data set of eating habits in this country, England, this is Northern Ireland, Scotland and Wales. Okay, I have the data regarding 4 countries and these are the 17 attributes that I have. Okay, now suppose I want to infer something from this. Okay, how these countries are different in their eating habits. Okay, so if I want to do that, okay, so yes, so what is my aim? I want to find the pattern in the eating habits in these countries. Okay, so from this number I cannot get any information. I have this high dimensional data space. Okay, I will try to reduce the dimensionality. If I go with only first principal component, now I can see some pattern here. Wales, England, Scotland have their cluster, okay, and Northern Ireland is far away from that cluster. If I go with the second principal component, still I can see the pattern. Okay, so this Northern Ireland is far away and they are forming one cluster. Okay, now what we can infer here? Okay, so Northern Ireland is having somewhat different eating habits. So now let's check, observe the reading for Northern Ireland. Okay, so first feature is alcoholic drinks. So it has less number here. Yes, so Northern Ireland is different in alcoholic drinks feature, right? What about beverages? It is somewhat similar. Okay, then for this meat, the third feature, they all have similar kind of values, but Northern Ireland has the highest value. Then regarding cereals, they all have the average values. Regarding cheese, the Northern Ireland has the least value. Yes, so in all the feature we can find out that Ireland is having either the highest or the least value. Okay, then what about fish? Again, Northern Ireland is having the least value. Fresh potatoes, it is having the highest value. Okay, so and with the help of only single principal component we are able to find that Northern Ireland is different. Okay, so that is the significance of principal component analysis. Okay, so from this 17 dimensional data set we can reduce its dimensionality, still we can infer something from that reduced data set. Okay, have you got this example? Anyone?
Yes.
Right? Okay, so we are able to find that variance which was present in this data set. Okay, that is PCA. Now I can show you the actual Great Britain map and see how geographically they are different. So if you see their map, so here Northern Ireland is not mentioned, so England, Wales and Scotland, so we have these three countries, and Northern Ireland is here. Okay, so they are geographically different also. Okay, this is the biggest island present in the United Kingdom. Okay, so they have similar kind of readings. Okay, and Northern Ireland is, see here, England, Wales and Scotland and Northern Ireland. Okay, so with the help of this simple technique we have seen that how Northern Ireland is different from these other three countries, right? Now, so behind the scene, how to find this principal component? So what we do here, so we'll find the covariance matrix. We'll find the covariance matrix of these 17 features. Then we'll find the eigen values. So in, I think, Math 3 you have might have studied how to find eigen values and eigen vectors, right? So we find the covariance matrix, we find the corresponding eigen values, we sort them and we select the eigen values with the highest values. Okay, so suppose you want two principal component, select the highest two eigen values. Corresponding to that you find out the eigen vectors, and those eigen vectors will be these principal components. Okay, so that is the mathematics behind that. So I repeat the process. You find the covariance matrix of this attributes, you find the eigen values, you sort them, you select the highest eigen values, find the corresponding eigen vectors, and those will be your principal component. Okay, so this is regarding PCA. Okay, so this is how you can reduce the dimensionality. Okay, so any doubt? So please take the screenshots of today's class. So we started with this feature engineering concept. Remember this flow chart. So you will have a raw data, okay, that is coming from sensors or any other source. Then you pre-process that, and this is pre-processing. Then we can go for the feature engineering. Okay, either select the best k features or reduce the dimensionality. Then you give that to your ML algorithm. Okay, done. Next we have seen feature selection. Okay, so here we find out the subset of features, right? Subset of relevant features, and we have seen the benefits that we get using feature selection. Okay, done. Next we have studied feature reduction. So here we reduce the dimensionality. Okay, and we have studied PCA, okay, briefly. So we have separate library for PCA in sklearn, and these are the articles that I have used. So I will be sharing the links in the classrooms. Okay, so this is very good article, okay, where you can visualize how PCA is working. PCA is widely used in image processing also. So this is the color image which is reproduced using PCA. Okay, so in color image you have RGB values, okay, and each value varies from 0 to 255. Okay, so you can see the dimension, it is very high dimensional data, right? So this is the image which is reproduced using the first 26 principal component. Okay, so 256 multiplied by 256 multiplied by 256. Okay, that is the dimensionality of the input image, and that is reduced to only 26 principal component. Okay, using this only 26 dimensional data, you are getting this image, and we can see some information, right? We can guess the image. Okay, so that is the power of principal component analysis. So it captures the variance very nicely. Okay, so mark the attendance.